Okay, so here's a tube head, which is the metal housing that contains the x-ray tube and that makes the dental x-rays. Let's take a look inside. Okay. Here we have the step-down transformer and the step-up transformer. The step-down transformer is what is going to decrease the voltage from incoming volts used by the filament circuit, and the step-up transformer increases the voltage from incoming volts. And so the process is initiated by pressing the exposure button. This permits the current to enter the filament, and we actually have the filament right in here in this bottle of the current of the x-ray machine. The step-down transformer reduces the voltage before it enters the filament circuit and heats the filament of the cathode. And here's the cathode right over here. We have it labeled, which separates electrons from their atoms. And it actually is what supplies the electrons needed to generate the x-rays. Okay, so these electrons are now in a state of excitation as they hover around this tungsten filament under here. I can put this up. This tungsten filament right in there. And that is actually recessed in the molybdenum focusing cup, which is represented right here as well. So the line current enters the cathode anode high voltage circuit, and the step up transformer over here will increase the voltage, which will impact sufficient force to propel free electrons towards the focal spot on the target at the anode. We've got the anode represented over here, which converts electrons into X-ray photons, representing a positive charge. Okay. So these high velocity electrons are stopped and slowed when they collide with the tungsten atoms on the target. This results in production of general radiation or characteristic radiation. So 99% of the kinetic energy that is generated is lost as heat energy. Approximately 1% of the kinetic energy is converted as X-ray energy, and that is how X-rays are formed. So now I'll just explain parts of this operation that I didn't go over when explaining how X-rays are produced. Here we've got the position indicating device, the PID. It's lead lined and it aims and shapes the X-ray beam, and the X-ray beam will actually exit the tube head at the opening of the PID port, and this would be the PID port. Let's go to the base over here. Here we have the lead collimator, which restricts the size of the X-ray beam. And over that, we would put these aluminum discs, which filter out the non-penetrating longer wavelength X-rays. So we put those there. And then covering those, we have a seal, the tube head seal, which will permit X-rays to exit the tube head, and it will seal in the oil and filters the X-ray beam. So that will actually come up here and cover that, seal it. Okay, kind of as explained earlier, here is the copper stem, and then the tungsten target is represented by this orange cup. So the tungsten target actually serves as a focal spot, will convert the X-rays into photons, which produces two types of X-rays, the general radiation and the characteristic radiation. The copper stem is what dissipates heat away from the tungsten target. And then if we look right in here, we have the beryllium window, which is a small number of X-rays exit the X-ray vacuum tube through this unleaded glass window. So it's unleaded. And then let's look right here. We have the X-ray vacuum tube, leaded glass tube that contains the cathode and anode, heart of the X-ray generating system. So what's represented on both of these sides would actually be within this. We have this string that comes in here, which is representing the filament circuit. and that provides power to tungsten filament in the cathode. So again, the tungsten target is there. And last but not least, as we can see, there's a covering of yellow paint throughout this, and that's actually representing the insulating oil that surrounds the X-ray vacuum tube and transformers, which prevents overheating. And that is my full presentation on how X-rays are produced and of my tube head.